Hey kids, it is me again, and we are going to be doing Throwback Thursday. Throwback Thursday is when I go back and review a standard or something that we've already done before. Now, I'm not going to be throwing it too far back this time. I'm going back to last week or the week before when we did division. I know that dang division, it is coming back to haunt you. Just kidding. And more specifically, we are going to be doing what we call long division. Basically, we are going to be looking at the traditional method. We're doing multiple digit by a single digit or a multiple digit by 2 digit. It's actually pretty simple. So we're going to start with, I'm on one side, I'm going to do partial product, and the other side, I'm going to be doing the traditional method so you can see how they relate to each other. So, and I think once you see it this way, you're going to be like, oh my gosh, this is so much easier. Sorry, I cannot write and talk at the same time. So on this side, we're going to do partial product. And then we will look at it traditional method. And your parents, this is the one they love. They love the traditional method. You know why? Because it is how they learned. It is how I learned. It is how we all learned before, as Mr. Boatwright calls it, the voodoo math. So here we go. All right, so partial product. We are going to start with 679 divided by 5. And I'm going to use this bracket, 679. Now, I'm going to write that over here as well, because we are going to come back to this method, 679. I want you to see them side by side. I'm going to do this one first. When we do partial product, we do a fun little thing called the waterfall. I know that seems silly, but that is what it is called. It is called the waterfall. Okay. All right. And the reason it's called a waterfall, because I'm going to go ahead and draw myself a little cliff, like a waterfall right there. Okay? I know, just stick with me. I know it seems a little crazy. Okay? All right, so first thing I'm going to do is I'm going to look at 5, and I'm going to look at 679. Now, I know that if I multiply 5 times 100, that's going to get me pretty close to 600. Okay? So I am going to start by doing 100. 5 times 100. Okay, so I'm going to start here, 5 times 100. Okay, and I'm going to then write 500. Actually, you know what? I'm going to do it in this color so you can see that. 500. And I'm going to subtract that. And I am going to end up with 179. Okay? Now, when I look at this, I'm going to say, oh, 179. Well, I know I could probably get to 150 because I know 5 times 3 is 15. So why don't I try and multiply by 30? Because 5 times 30 would give me 150. So let's try that. Let's try 150 multiplied by 30, and let's see what I get now. So if I subtract, then that gives me 29. Well, I know I can get really close to that. I know that 5 times 6 is 30, so that's too much. So I'm going to have to go lower, and I'm going to have to go with 5 times 5. So let's see, 5 times 5. is 25. So if I subtract that, that will leave me with 4. And we know that when we end up with an amount that is less than our divisor, that we have, now we've come to a remainder. So what I'm going to do is I'm going to add this together. That's 135, and I have a remainder of 4. Now, I actually did this in really large chunks, and you might do it in smaller chunks. Eventually you will get to the same answer. Your waterfall might need to go a little bit lower or a little bit longer, and that's okay. I just chose these numbers because I wanted you to see how it relates to our traditional method. So now we are going to take this and we are going to come over here. And now what I'm going to do is I am going to think about these as just digits. I'm not really going to think so much about place value. I'm just going to be thinking 5 and 6. So 5 times what? Okay, I'm going to be thinking about multiplying. 5 times what will give me close to 6? Well, I know 5 times 1, or 1 times 5, is 5. So if I subtract that, 6 minus 5 is 1. And I'm going to bring down my 7. So now I have to try and think about 17. Okay, so now I'm thinking about my 17. So looking at just 17, 5 times what will get me close to 17? Well, I know 5 times 3. 3 times 5 is 15. If I subtract that, that gives me 2. I'm going to bring down my next digit, which is 9. Now I have 29. So now I have to think about how can I get to 29. 5 times, which we already talked about over here, 5 times 5 will give me 25. I subtract that, I get 4. I don't have any other digits to bring down, so 4 is my remainder. Okay, so you can see, just look it over. Think about what makes them similar, what makes them different. Okay, so on your notes, I want you to write this. What makes them the same and what makes them different? And I want you to take a few minutes and I want you to answer this question on your notes. Okay, so pause, write this down, write down what makes them similar, what makes them different. Okay, and then come back and we're gonna do one more problem together. This one will be a little bit more difficult. So jump on there real quick and get that part done and then come on back. All right, guys, so you should have answered this question. So I'm gonna leave a little space so you can do that to show that you've probably filled some of this in. And now I'm gonna take a problem. I'm gonna go a little bit more difficult. You will not have to do it with 2 digits. I just want you to see how easy and simple this is to use both of these methods. So I am going to go with the number 12, and I am going to be dividing 195. Okay, now if you want, you can pause and try it on your own and see what you come up with. In fact, that's actually probably a pretty good idea. But if you're really not feeling comfortable and ready to do that, just do this with me. Okay, so first thing I'm going to do is 12 and 1. If I'm just looking at that 1, okay, just looking at the 1, well, I can't do anything. 12 doesn't multiply to get 1. So I'm going to go ahead and expand that, and I'm going to look at, I just messed up. I'm supposed to be doing that over here. So here we go. I'm going to do something different. I know, I'm going to make my waterfall. I know, it's fine. I made a mistake. You don't have to put that little red line. You can ignore it. And over here, so I'm going to be thinking 12 times what can get me close to 195. Well, I know how to multiply by 10, so I'm going to multiply by 10. Okay, I'm not really great at multiplying by 12, but I do know how to multiply by 10, and I know that 10 times 12 is 120. Stop laughing at me. I know I made a mistake. You can stop laughing. Hey man, I'm human. We all make mistakes. All right. So now I'm going to go ahead and subtract 195 minus 120 is going to give me 75. Okay, and so now I do know that 12 times 5 is 60. I know how to multiply by 10s. I know how to multiply by 5s. That much I know. I know that I can do 12 times 5 is 60. Are you still laughing because I made a mistake? I can hear you laughing. All right, and 75 minus 60 is going to give me 15. Oh, look at this, I'm getting closer. And, well, then the only thing I can really do is multiply by 1. And guess what? I know how to multiply by 1, 5, and 10. And 1 times 12 is 12. And I subtract, and I get 3. There is my remainder. But then what do I do with this? I simply just add it up. 10 plus 5 plus 1 is 16. Remainder 3. Okay, so there is my answer. Now, going back to what I said over here, going to the traditional method. Let's give our little woo, we're going traditional, yay. Okay, so right here, so I know that I cannot get 1 multiplying by 12, but I can get close to 19. 12 times what will give me close to 19? Well, I know 12 times 1 will give me 12. And if I subtract that, I get 7, right? I get 7. 19 minus 12 is 7. I'm going to bring down my 5. Now, I know 12 times 5 is 60, but that's going to leave me too many left, and I don't have anything else to bring down. So I have to go up 1. So let's try 12 times 6. Well, 12 times 6 just happens to be 72. I subtract that. What do I have left is 3. So there is my remainder. And that goes up top. And so notice I got the same answer. I just went about it slightly differently. Okay, so remember when I said over here, I knew that 12 times 5 would give me 60, but look, that wasn't going to give me enough. I was still going to have 15 left. So I had to multiply by 6 and check that out. There's my 6 right here. I just did it in 2 pieces on this side. So when you do the partial product method, it does allow you to take in smaller chunks and use the multiplication facts that you are more comfortable with. If you are really good at your multiplication facts, this is going to be a piece of cake. Okay, so easy peasy lemon squeezy on that. And we are done for Throwback Thursday. And tomorrow, a new day. Tomorrow is Fraction Friday. I cannot wait to share. So make sure you bring your markers, colored pencils, crayons. You are going to need them tomorrow, okay? All right, so bye guys. I will see you. Peace out, my home fries.